Hello and welcome to Mr. Davis's math class. This is Algebra 1 and today we're on lesson 6.5. Today we're talking about linear inequalities and we're going to do a couple things. Today's lesson we're just going to learn how to graph and an introduction to linear inequalities. So here's your guys' warm up. I'll go ahead and try that before we move on. All right, so we have some vocab. Today we're talking about linear inequalities, which are just pretty much the same thing as equations. The only difference is we have these inequality signs instead of an equal sign. But other than that, it looks pretty similar. In fact, if we look at this one, we'd probably say this is slope-intercept form with a linear inequality. One important part is when we talk about a solution of inequality, we're talking about an ordered pair that makes the inequality true. And I give an example here of that same one where we plugged in 1, 3. If I plug in 1, 3, it makes it true. And unlike a solution of an equation, there are many solutions of an inequality. So there's not just one, there's going to be lots. All right, so here's problem 1. It's talking about is the ordered pair a solution of that inequality. All right, so let's start with A. 1, 2. Now, when I want to know if it's an ordered pair, I'm going to plug those into the appropriate places. So y is 2. It needs to be greater than 1 minus 3. All right, where this was, let's see, the 1 went there, the 2 went there. And now we need to do our math. So we get 2 on that side. The 1 minus 3 is a negative 2. And then I need to think to myself, is 2 larger than negative 2? And the answer is yes. This is a solution. And it's as easy as that. Let's try B. So again, instead of a y, I'm going to write negative 7 is greater than x isn't my negative 3 value. Negative 3 minus 3. I get negative 7 is also negative 3 minus 3 is negative 6. Is negative 7 greater than negative 6? And that answer is no. Negative 7 is more negative, making it a smaller number. So this is a no solution problem. All right, here's one for you guys to try. If you need help, refer to the previous problem or your notes. All right. Next, we're going to talk about graphing these linear inequalities, which they're going to graph very similar to equations with two differences. Okay, one difference: we have to decide whether it's a solid or a dotted line. All right. So here they give an example: one's solid, one's dotted. You can tell whether it's solid or dotted from the inequality signs right there. Anytime it's got the line underneath, like the one on the right, see how it has the or equal to sign right there? It will be a solid line. So basically, you need to remember, if there's a line underneath, it's going to be a line. Over here, where there's no or to equal to part, it's a dotted line. So if there's no line, it's a dotted line. The next part is you might notice that there's some yellow shading. Okay, and so you're going to shade half, and we're going to be either thinking about shading above the line, like the one on the left, or shading below the line, like the one on the right. We'll get into, once we do one, we'll talk about whether or how to graph shade above or below the line. But those are the two differences. Other than that, it's got the same starting point. But look at this one, right? Starting point's at negative 1. They started at negative 1. The slope was up 3 over 2. They went up 1, 2, 3 over 2. Right? So it graphs the same way with those two exceptions. So looking at this one, right? We're going to graph this one. First off, let's think: dotted or solid. Right? And the answer here is dotted, right? There's no or equal to sign. There's no line. So it's not going to be a solid line. It's going to be a dotted line. Then I needed to think, what's my starting point? All right, and remember we think about that, that's our y-intercept. My y-intercept is a -2. Okay. Then from there, I need to know what my slope is. My slope here is 1, or up 1 over 1, so up 1 over 1. I need to draw my dotted line through those 2 points. There we go. There's my dotted line. And last piece that we need to do is shading. Okay. All right, so shading. There's kind of 2 ways to do the shading piece. One is from a test point. Which basically means I'm going to pick a point to see if it makes the inequality true, like problem 1 from today. So I'm going to pick one, and it can be any point that you choose, as long as it's not on that dotted line. Probably the best one to get in the habit of choosing is 0, 0. Zeros are pretty easy to do math with, so it makes it pretty simple to test that point. So if I plug in the point, let's see, this is 0, 0, right? That means 0 for y, 0 for x. If I do my math, I get y is larger than, or 0 is larger than a -2. Is 0 larger than -2? Yes. That means this is the true side. The other side has to be false, and we shade the true side. So we end up shading the half with the test point. If the test point was false, we'd have to shade the other side, the opposite side. Now, that's using the test point, which is kind of the way the book teaches. It's kind of a standard way to do it, but what I've noticed is that most people can do this intuitively, okay? So I think about either shading above the line, so either above up here, or below. Okay, so either above the line or below the line. Now if I think about this as inequalities, then above the line, would it make sense that above the line is a greater than sign or a less than sign? And it probably makes this a sense that above is greater than, or one of those 2 symbols. And below is a less than symbol, right? Or one of those 2. So if I come back to this problem right here, my symbol is a greater than symbol. So if it's greater than, I'm going to shade above the line. And it makes sense to think about it as being above is greater than. And that's where I shade. So there's 2 strategies for shading. Right. So now you guys know how to graph. Here's an example problem for you guys to do. And here's your homework. All right. Please have fun.